Sorry for the delay. We all wanted dessert, but I appreciate everyone being here. I also want dessert, but you get to learn about Kafka and Apache Pulsar. And I also have stickers. They're not Kafka stickers. They happen to be Plumie stickers. So afterwards, if you stop by, you can have some free swag. All right. So I want to say that basically this talk is not still. Okay, great. This talk is not about Kafka being bad and that like Apache Pulsar is the winner and we should just drop Kafka and replace Kafka every time. And it's not a talk that's focused on event streaming itself. So it's not you come here to learn about event streaming. It's more about like, let's do a comparison of the different tools. And then I want to talk about some of the use cases for Apache Pulsar. So first I want to start with like, is anyone using Kafka in the room? Okay. Is anyone using Apache Pulsar? Okay. Has anyone heard of Apache Pulsar prior to this talk? Okay, so this is probably actually a really good audience because a lot of you have familiarity with like what exists and you've heard of this other thing, but you're not using it. So hopefully after this, you will have an idea of why you should be using it or where to use it, I should say. So we want to just, the outcome of this talk is recognize where Pulsar can be used and the benefits of Pulsar. And then we're going to talk about how we can get more out of Pulsar with less resources and less of the burden that I had with Kafka. Now, I know myself when I'm at the conference, a talk like this, I will see intermediate, and even though I might not be intermediate, I still attend. So for the very basic intro to event streaming, for anyone who has never looked at this, what we're talking about is basically like on the left side, we produce a message, it goes into something. The thing it goes into is kind of what we're talking about. That is Kafka or Apache Pulsar. You have your consumers consume the message out. Like I'm simplifying, but for anyone else who maybe came in the room is like, it looked interesting, but I don't know what we're talking about in event streaming or what Kafka is. That's kind of what we're talking about. It's just a place where we're storing like messages, and then there's like replayability, and you're producing messages in, and you're pulling messages out. But that's really it in the most simplistic way. So you might have seen my bio, so I won't go into like really who I am, but I did want to talk about my experience with both of these tools to give context at the size it is. So for Kafka, it's at a prior company, and it was about 2 years of complete exposure with that, running in like a analytic team there. And we daily produced about 2 million messages. That was our incoming. And peak was about 650K per second. And then where I am today at Blue Cat Networks, so I've been using Pulsar for about 3 years. It was from the ground up. There was no Kafka. And we produce about 10 billion per day. And at peak, we well exceed over 1 million. It's just for context of like, some of the things I say today, you're gonna be like, I never had that issue, but it's all perspective of the size. Like maybe you don't have the issue at like 100 million messages, but at billions and like petabyte of storage kind of scenario traffic, you kind of do. So how did this all begin? So at Blue Cat, they came and they're like, come here and build our entire data team and platform from scratch. And that was back in 2019, and they're roughly about 400 employees. And I had done this prior at the bigger company. What they really meant to say to me was achieve what you have already done, but with 1/5 the resources. So that meant I couldn't just apply the prior stuff I was doing with Kafka, and I had to revisit the problem. Like some of the pain I had felt from Kafka was this. At the time, it's all context, and there's been Kafka improvement plans, so KIPs, that have addressed some of this. But at the time that led me down the Pulsar path, I was like, there is a clear lack of replication as a first-class citizen. At that time, there was something called MirrorMaker V1, and it partially worked. Half the time it broke, and Uber and Lyft wrote V2. So I don't know what the state of replication is today, but it was just something to start to get me to look outside of just Kafka. I knew it was an industry standard and everyone defaulted to it, but I had enough pain with it that I started saying like, there's gotta be something else. And it worked at the prior company I was at, which was like 2,000 employees, but we had tons of special in-house tooling around broker management and rebalancing and monitoring that we made it work for us. So for the stat I always hear is like, yeah, but Cory, why have you used Apache Pulsar when Netflix is using Kafka? Yeah, but Netflix has 1,600 Kafka clusters. They have an entire tool set where every cluster can be torn down at any notice from one AZ to another, entirely automated. Like we're not all in that spot. We don't all have the resources to build out these super fancy automation tools, right? I need something that kind of makes it work for me and not build on top of it. So my mission was basically attempt with less resources, and I want no special tooling. I want zero to small operation team, and I don't want to train Kafka specialists. So I don't know how many of you have used like Apache Elasticsearch or OpenSearch, the equivalent. But that was kind of magical for me because I've been able to use those up to about a petabyte, and all I've done is just add or remove nodes, like, and kept the shard count under 50 gigs. Like, that's it. Like with Kafka, like I don't even get close to that. It's like, okay, there's Zookeeper allocation, there's tuning on that. Now I have a broker management. Now I have to build this tooling to automate if a broker goes down and the broker ID goes up and the replication doesn't auto recover. And now I have to keep check of hotspots and is it good rebounds? Am I doing that? And now I have to like, I wanted something like Elasticsearch where most of my operations was adding and removing nodes, and that was basically it. So time to look at our options. So napkin requirements were these. And so obviously the big thing was reduce operations, but better performance or better cost was a major consideration. And the 3 was like the biggest thing you would see. So if you ever want to do this yourself, you will have tons of resistance because Kafka is essentially the IBM choice of the prior day. Everyone bought IBM because it was a safe choice. Kafka is the industry standard. It's the safe choice. Doesn't actually mean it's always the correct choice, and maybe it is the correct choice for your spot. But it's so defaulted to what people do with event and streaming that everyone just is like, well, obviously we're going to use Kafka. And I actually faced this at Blue Cat. I proposed something, and immediately everyone in that meeting was like, of course we're using Kafka. We don't even need to talk about what we're using for the event streaming. And it's like, actually, I think we're not going to be using Kafka. And they're like, what do you mean? Like, it had so much friction and resistance that basically number 3 was critical. Like, we couldn't just do the same. I had to go further than that to justify to other people in the company that like going a little bit against the grain of industry standard was all right because, and fill in A, B, C, D that we'll cover. So operations, we talked a little bit about it. Like these are 3 things that we're going to solve with Pulsar. And like I said, I haven't used Kafka in a bit, so some of these might be already resolved in KIPs, but at the time, this was the main consideration. So handling broker failures, like I didn't want to have an outage and know what broker IDs were. Like at the time, if broker ID 3 went down and I want to spin something up new, I had to actually specify that that node was broker ID 3. I don't want that. I don't want to build tooling for it. I know I can build tooling. I would much rather first-class system. I want that Elasticsearch vibe. I add nodes, I remove nodes. Everything else is magic. Auto recover, auto recover. Balancing expansion, same thing. I add nodes. I don't want to optimize for reducing hotspots. I don't have to worry about adding a new node is going to create like thundering herd because now something moves over there and now all the writes are going there. I wanted to just do it, just like Elasticsearch. I wanted to add in some sort of small segments. And then we talked about the replication issue. At the time was just totally broken. It didn't really exist. It was an open source project that kind of solved it. But I just want something as a first-class system. Because it's always a question of not if we're going to have an outage, it's a question of when. So, so Pulsar on the broker stuff, the way that we're going to get into this is essentially we're going to skim over some of the internals of Pulsar, and I'm just going to try and keep to the terminology of Kafka. So broker and broker, we'll just say is the same thing. These segments is a subset of a partition in Kafka. So Kafka is using partitions. We'll say that Pulsar is using the exact same thing, but it happens to introduce a more subset resource called a segment. Kind of really similar to the Elasticsearch model, right? You have an indice, and then your lower stuff is shards, right? So on a broker failure, what actually happens is I don't have to do anything. The segment will just move. If you have a subset of your data corrupted on the broker, just that segment will move. So in Kafka, your topology is that partition is the unit. So if any of the partition gets compromised, you actually have to restart the entire partition. That partition must be restored. So that creates all this overhead of replication. Here, you have just a subset. So if a segment was to be in a corrupted spawn disk, just that segment will be repaired. Just that segment will move. Now, if the entire broker went down, all those segments will be obviously re-replicated elsewhere. And I don't do anything. The auto recovery functionality in Pulsar, this all happens. This happens, I don't want to say all the time in the clusters I have. I'm not saying they're unstable. I'm just saying these have happened and we haven't even realized. That is a very good spot to be in. The same thing, if we talk about balancing and expansion, I just add nodes. So Pulsar's, when you add a new node, it will determine what segment should move there. It will pick the lower red and lower right segments, and it will balance out how much of the new segments are going there so you don't overwhelm that new box that you add. The same thing for expansions. I don't do anything. I don't set a broker ID. I don't add anything. The only thing is they just can't have conflicting host names, but like that already happens when I spin up new nodes. And that's it. They join the cluster, they authenticate. That's all my operations is adding and removing nodes. So, and we haven't tuned anything. I'm running at 10 billion messages a day, and we have not tuned even JVM arguments. Like, we've increased the memory, but we haven't even changed like what the default garbage collector is. We haven't gone into like what we're doing on the broker sizes or anything like that. We're basically just mostly adding and removing nodes. There was one caveat in the past where we did have to optimize the max reads at a time, but that was because we were using elastic block storage, and that's since been patched on the prior version we used. But that was it. So I want to talk about the replication thing. So in Pulsar, this is fully achieved. This is first-class citizen. It's right there. There's no third-party tool. There's nothing else you run. You have 3 options. So full mesh, which is n clusters. So I can set up 3 clusters and have them all replicate between each other. So 2 is a subset of 1. That's just when we're talking like data center A and data center B, 2 clusters. That's more your active-active, like I want a backup or I want to have a secondary that's also taking writes, or maybe it's just a passive that doesn't normally take writes. That's fine. And then there's a different kind, which is aggregation replication. Not many people are going to use this. It's like, imagine you have things like, I have clusters in each region, but the operations team wants all those logs to go into one central cluster. So I can have all these fronting clusters go to one central cluster for like log aggregation or billing aggregation or whichever you need. So the individual clusters are not replicating to each other, but the central one is. It's a spoke and hub model. So you have a bunch of spokes, one central hub that they go to. And they might say, this sounds very great, super complicated. No, it's less than 6 lines in the CLI. Not even kidding you. Like, it's literally, we could pull up the docs, it's 6 lines. All I do is to specify the topic and what clusters it can replicate to. Now, the nice thing I just said there is which clusters. So not only do you get replication, but you get to choose how the replication works. So let's say you want to do topics to particular clusters. Let's say you have, I know it says APAC, but let's say it's US West. You have the US government as a customer. And they say the data must have a backup, but it cannot leave the US soil. No problem. I have a cluster in US West and a cluster in US East. And in Pulsar, I say that these replicate for this, but they do not replicate to EU. So you can maintain data residency as well. This, to my day, like to my knowledge with the KIPs, this is not even achievable. Like, cool, you have replication maybe with Mirror Maker or whatever Kafka has today, but can you choose which clusters you get? And can it be under 6 lines and that's it? Like, and you can do further than 6 lines. Like 6 lines is like, I just want X to replicate in these areas, but you can do HCL too. Only these topics can go, only this kind of stuff can go. I want to do it in this kind of batch. I want async or synchronous replication. There's a lot of extensive stuff, but I consider replication like checked off for this. So let's talk a little bit about the performance or better cost. So this wasn't like it had to work. I just knew I couldn't have a subset. I couldn't go backwards. I couldn't go to something that was going to be worse performing or more costly. So the way that we're going to talk about Pulsar on this is like the architecture is a big difference. So on the right side, the compute and storage in Kafka is combined. So you have your brokers, and they are the serving and storage layer. In Pulsar, these are split. You can combine them into one box, but in Pulsar, what this is actually is technically the broker is just the compute, and there's something called a bookie, which is just the storage. You can run them on the same box, but they can be entirely separate boxes. Okay, what benefit do we get there? Well, all my compute, I can just pick like AWS instances on CPU, and all my storage nodes, I can just pick the i3 instances. So now I'm not compromising on performance. If I combine these, I have to pick a general instance type that not only is going to serve for serving, but also storage, which is not great because like they're different things. My storage layer might only care about memory and just IOPS. It might be very little CPU. And the compute is mostly network and only CPU. And maybe it cares a little bit about memory on like tail reads and things like that, but like, so you can optimize on this. This is actually like an understated thing that really unlocks a lot of the capability of it. Like, we're a very small cluster for what we do. Like, we're under 50 gigahertz and probably under like 300 gigs of memory. And we're just using EBSs and not even provision IOPS. And we're pushing 10 billion messages through it. Like, yeah, every day actually, sorry, not total. So this is actually where you get a lot of the different performance stuff and cost optimization too. Like I can take out reserved instances just for the compute and just for the storage. I don't have to pick general stuff, but I think you all get the point. So it's a lot, don't worry. Don't even worry, okay? Don't really look at it. Just know it's a lot. So let's talk about Apache Bookkeeper. It's a lot of stuff. So how do you get Pulsar to be so performant? Well, because they're leveraging the Apache Bookkeeper. And the reason why I show you so much stuff is, okay, we have to worry about like wall files and recache and write cache and caching and when do we cache and when do we not and what is log entry? Did it get right? Did it not get right? Is it synchronized? Okay, but Pulsar gets this for free just by leveraging Apache Bookkeeper. See, the burden is that on the Kafka side, they have to maintain this. This is the work that they're doing. And for me, what I've seen in the community is like the open source Apache Bookkeeper community continues to just get better and better and better. And the Pulsar project just gets this for free, right? Like this is a dedicated project just for this problem of storage and writing and reads and tails and heads and like what wall files and when do we write and how do we batch. Its sole purpose is just that. So they don't care about like the authentication portion or how do we have a proxy in front of this. It's just the storage layer. So anytime I've done side-to-side comparison, it's always been equal or greater. I've never had a scenario where I've gone way back. And the reason why is, like I said, it's not to understand this. It's just to understand that there's a lot going on that we're leveraging just on open source, another project that does this very well. So enhancement options. There's a bunch of stuff. And honestly, I've done this talk in the past, and I used to have a slide that showed all the things. There's 25 other features that I could identify that like Kafka doesn't have, but these are the highlighted ones that I think people here will care about. So functions, they actually exist. So left side, this is Pulsar, and on the right side is more typically what you're doing with Kafka. Technically, there's Kafka SQL too, but that's just a way of interacting with it. So on Pulsar functions, I can actually run my code right on the broker. So I can run it right where the brokers are. Now that's good and bad. You could also run them not on the broker if you like. There's pros and cons to this, but I can run it even closer to data. And now I get what would be referred to as function as a service. So I don't need Flink and I don't need Spark. And I get window batching, I get per message, I can get all the deduplication stuff that I normally would use Flink for. I'm still in the Pulsar world. So there's like a little SDK in Go, Java, and C#, I believe. And now, like, I don't have to learn about Flink. I don't have to worry about state management. I don't have to worry about did the job manager actually crash, and did the task manager crash or not crash? Did I continue running? Like, I can run a Flink Kubernetes operator for this, but like, Pulsar just has it. So it's kind of like, think about it as like you have this streaming platform, and then someone said, okay, AWS Lambda, that's runnable on top of it. You're like, cool. It's one less thing. And it solves like 99% of the time of what I want. Like I'm only using Flink for these heavy lifting things where it's like windowing and processing and moving around to different topics or subset. I think that's the question. Yeah, yeah. So I haven't really looked at Kafka streams, but I'm pretty sure on the Kafka stream stuff, do you run, well, I don't think you run it directly on the brokers. Okay, so that's one thing. And then the rest would be comparable, I guess. So, and I don't know enough about, honestly, like, do you have the same functionality as like Flink and Spark on windowing and state and, okay. Okay. So I guess the big thing here is just being able to run it directly there and not have to manage it. So like, it's been a while, so I'm not like, take it with a grain of salt on like, you might be sitting here like, no, Cory, actually 2 months ago, the new KIP came out and it's totally, I'm like, okay, like I know this might've been around for a while, but, and then, so Pulsar SQL, not to be confused with Kafka SQL. These are not comparisons. So the diagram has a bunch of stuff, yes, but all Pulsar SQL is actually uses a different project called Trino. It allows us to write SQL. It allows us to go out to the broker and say, hey, you have some metadata for me. Tell me where this stuff is stored. Cool, great. Let me go get that from the storage layer and don't go through the broker. Because the big thing is, if I want to run like I want to run a giant batch analysis, I don't want to go through the same path as the real-time data, because now I'm competing for throughput on the brokers. Like all our normal traffic is going through the brokers, and now I want to do some batch stuff. What I actually want is basically to go to the storage layer behind and go directly to what is called the bookies from Apache Bookkeeper. And the irony is also Kafka and Pulsar both support tiered storage, but here I don't even need to go to the bookies sometimes. Sometimes I get the metadata and it says, oh, the stuff you're looking for is actually in S3. Cool, because guess what? I'm just going to hit Amazon with more API calls. That doesn't impact any of my normal stuff that's happening on the streams, like either the functions or Flink or Spark. I really want these separated. I don't really want to mix my real time with my batch. Like I want them separated. You could run separate clusters, but it's just a nice fact that with the Pulsar SQL, I can write the SQL and go directly to the storage layer and just say, hey, I'm not going through this typical broker way, because you're not a consumer here. You're not actually acknowledging the messages. You just simply want to look at the data. So subscriptions, there's 4 different types. Exclusive, where we have one consumer that's exclusively there. You have a failover, so consumer is there, but if it so happens to fail a health check, the other consumer will take over. The shared one, which is the more common approach that most people are using, which is like the fan out thing. You have many consumers. I just want to read from a topic as fast as possible. And then you have the key shared approach, which is more like this consumer is only looking for a particular key. It should always get this kind of key. Think about something like if your topics are filled with like user IDs or IPs, and you want the consumer to always get the same kind of stuff, maybe because it has a cache or it's doing aggregation based off of that, then you would always want the same kind of stuff to come back. But you actually can choose any of these. And you could set up other consumers like a mix. You could have a consumer that's exclusive. You could have another consumer that's shared on the same topic. So just like the extensibility and flexibility is like, wow. So retention, this is probably the biggest thing that I've noticed. So with Pulsar, you have a ton of options. Like there's a ton. So one of the things that is key on retention is I can set it to be infinitely stored. So just store this message indefinitely. I can set it for disk space, store the messages up to a certain amount of size. You can set it by time, store X messages up to 1 hour. I can set it for a combination. Over the past 3 hours, have you stored more than 10 gigs? Yes, don't store the message anymore. You can do it for unacknowledged or acknowledged. So keep the messages, if they're not acknowledged, indefinitely, because it means the consumer has never consumed it. If the message has been acknowledged by all consumers, now drop it after 1 hour. Like the matrix C is so hard to explain because of the flexibility that I didn't have a really good way of being like, aside from like this, which is like, all right, so on the right side, it's acknowledged message, but it's been over 1 hour. So we get rid of it. The green ones are like, we have these messages, but we still have to keep it because we haven't expired a retention policy. We haven't exceeded our disk, or we haven't exceeded the time. Then the backlog is unacknowledged. So things that nobody has acknowledged at all. Any of our consumers have not acknowledged that. So then on the backlog, you would say the same thing. Keep it for X time or Y disk. And then you can say, like, if it's been unacknowledged, but it's been longer than 2 hours, I don't care. You could set this for like 7 days. So if no one picks up the message over 7 days, you just drop it. Now, the crazy thing about this, when you get through the matrix, is you basically realize, like, wait a second. So I have a queue, I have a pub sub, and I have event stream with replayability, and I can change replayability based off of time or size or indefinite. It's like, this is one solution to rule them all. Like, from the AWS world, it's like you've taken SNS, SQS, you've taken Firehose, and you've taken pretty much all three of those and just combine them into one offering. And he said, here, just set some config stuff and you can pick either or. This has been really a huge thing for me because there are some messages that's like, it'd be nice to get it, but honestly, like, it's not critical to the company. Like, if we're exceeding disk space, just drop it. If nobody has consumed it after 7 days, just drop it. Like, we just don't care. And there are some things that are like, no, we absolutely have to consume every single message, never drop it. Or replayability. How long do you want your new consumers to have data? Do you care about that? If a new consumer comes up, do you care if there's prior historical data in a topic? Some people do. Some people don't. And it also depends on how you set this up. Like, a lot of the pipelines we have, one of the first things, one of the first consumers that happens in the pipeline is it syncs to S3. I can always replay from S3. I can always replay it as a topic. So any of my new consumers that come on that want historical stuff, I would have a side topic that I would replay into, and those consumers would get it from there. I don't need to keep this huge pipeline. Like, that's the biggest thing here is when you set up this event streaming, one of the major cost factors is how big is your retention? Because if you're like, everything has to be there for 24 hours, it means, well, you have to keep 24 hours of data. What's your growth? What are you trending? Like, for us, it's like, imagine keeping like 10 billion messages every single day. And if your company says, oh, we need 7 days, 70 billion, and that's like average. So for us, once all my consumers have acknowledged, we immediately drop. So that pipeline stays super small. And you can do with Pulsar flexibility of like, as I mentioned, the tiered storage like Kafka has. So it's not bashed on Kafka. I can say 100 gigs on Pulsar, anything exceeding that goes to tiered storage. So on most of my operations, we're in EBS. Now, if there's a huge spike of traffic, it would go over to S3. But I can control that through a retention policy of how much do I want. I could set indefinite. So normally we're writing to Pulsar cluster, but indefinite. If all of a sudden you have this huge burst and we exceed all the disk space on Pulsar, and we need to keep those messages because we always have to consume them, it's going to S3. And also, by the way, on that note, it's abstracted. So the client calls into Pulsar, and it doesn't know if it's on Pulsar or S3 or GCP or Azure. It doesn't really care. What it cares is, like, I need that to come back. So multi-tenancy. So this paradigm is built into Pulsar. So you start with a tenant, and a tenant can have n namespaces, and those namespaces can have n topics. Why might we care about this? Well, what happens if you have a topic that, a topic that you want to have different policies or generic policy? Like, anything in the tenant called like Blue Cat and in the namespace billing should always have a policy set as indefinite, because it's going to be topics related to billing, and we have a compliance, or 7 years if you want to say that. Versus I have a tenant called research, and the research teams, they're just whatever, because it's not real prod stuff. And you could do this in separate clusters too, but I'm just giving an example in one cluster. There are other settings, not just on retention policy, that's going to be applied to. So I can do max throughput on the consumers. So I can do rate limiting based off the namespace. So if you have or the tenant, either or, how how deep you want to go is up to you. So I can have a tenant like prod, and then all of my normal namespace, and the tenant is dev, and I can cap dev to be like, you can't consume more than 100 messages per second, because I don't want you to compromise the cluster. Now, obviously, you could also isolate, but you might have things that are more critical to your business and your events than like the analytics loading on your page. It might be like, no, we use this for orders. Orders must always go through. So I'm going to throttle out on the analytics side. And this is first-class citizen. This is no hack. This is no like I did an application code. Like it's just there. You just define them through the API and you set the hierarchy. You can attach policy or the configuration to either the tenant or the namespace. And on the newer versions, even some of this goes down to just a topic. So if you want to override from the topic and namespace, you could do it. And then there's ACL for this too. So if you don't want your teams going in and go, yeah, Bob sent me to 100 messages per second. Yeah, right, 10,000. You could lock that down as well. So, but it's more sane, right? You give someone a topic and you tell them like, here's what you are because you're in the dev namespace, yada yada, and it's just very nice. It's not all rainbows and sunshine, okay? The functions, there's no WASM supported. There's been attempts to merge this in, so it means you must write those functions in Go, C#, or Java. That might be a deal breaker. You might be like purely a Python shop and like, hey, look, that's a big deal. For us, that kind of stuck because we have teams that are different languages, and it's like, hey, that team's not super familiar with any of those, and maybe we don't want to like. Maybe we're moving more towards a Blue Cat towards Rust, and it's like now we got Rust plus Java plus Go plus yada yada. The upgrading on the version we had, it was very painful and still continues to be painful, but in 3.x, they support live upgrades, so this is improving. The cluster will spin up new versions of the nodes on the new version. You're able to confirm everything's good, and then it's able to switch over. This is an observation. The Helm chart is not the best, to be honest, if you're running Kubernetes. There are better, there's another community chart from Stream Native, which is actually better than the official Apache one, in my opinion. And the other thing I was going to say is it's not a true like Kubernetes event streaming platform that I dream of. They'll tout it as like cloud native and things like this, but it's not the end all be all if you're just in Kubernetes. Like this has not filled my like, hey, this works flawlessly all the time and everything just works and it's a stateful set and it understands it's stateful, and like the Helm chart is very good. It has the rolling updates, it manages itself pretty well. We run it in Kubernetes, but it's not like that magic factor for me. Like you're like, wow, someone built this around Kubernetes. Instead, it was built standalone, and then someone said we could have Helm charts to deploy in Kubernetes. And you're like, okay, it works. Like, and there is a Kubernetes operator, but I have not used it. I just know it exists, so I can't really comment on it. And the crisis is like not obvious always to solve, but this is, in my opinion, fair to Kafka and both. Like when you're like, I don't know why we're having throttling issues. Like, where do I begin to troubleshoot this and whatnot? Like, I think both of them have the same issue. It's like experience and just building up this. And there is a doc page called the cookbooks, and they walk you through the day-to-day operation stuff. But like, it's hard to read through that stuff when you're like, prod's on fire. Oh my goodness. Like, how do we just prevent this? Like, but that's more like the operations experience. And I've had the same thing on the Kafka side. And I don't think there's a definitive bullet for this, aside from maybe like ChatGPT is so strong that you just ask and it answers immediately, maybe. Like, we'll see where that goes. So closing. So original questions is like, where will we use it? Like, you care about keeping your pipeline small, you know? You want single platform for pub sub queues and events. Like, it just opens up a lot of flexibility. I think a lot of teams look at Kafka for the event store and the replayability, and like they're looking at Flink and Spark and a lot of data coming in. But for me, running Pulsar has opened up a lot of other avenues where it's like, yeah, we're using it for that, but hey, you want this pub sub thing for this unrelated non-big data thing? Cool, we're already providing the cluster. It's already there. Like, all we're doing is just setting the retention policies different. The same thing for queuing. It's like, you can have it where it's in there, and the moment the consumers acknowledge it, you delete it. Like, cool. Like we've used it in that capacity as well. And then just when you want to run compute directly on top of the platform, but this is very rare. This is like you really, really care about performance. Like you're either like fintech or you have so much data that you're like, yeah, not making network calls is actually going to make a big deal for us. So getting more with less, because of the split architecture, we can do instance optimization. As I mentioned, we can reduce the pipeline size based off of retention and what our needs of the business actually are. And then there's just a lot more features, in my opinion. Like I said, we haven't even talked about like the full ACL that's built in, the fact there's a load balancer that you can put in front of your brokers, the fact that I can call into a cluster in EU Central. And you know how we talked about the replication and sometimes topics might not go to EU Central? But my client can connect to the EU Central cluster. And even though the topic's not there, what it'll basically get is a redirect. That cluster will go, I know that topic's not here. I know the topic is in the other clusters. So I'm actually going to be either a proxy or just tell you to connect to this different IP. So your clients don't need to know, like, where is that topic? Which cluster is that in? You're just like, you connect to the global cluster, any of them, any cluster, and it will just route you to the spot you need to go to. And I know this seems very tiny for some people, but it's like, when you have teams and you have different clusters, like you have 5 clusters in different regions, and people are like, yeah, but I just want the US data cluster only. Which one is it? And where do I go? And I can just tell them, like, here's my Anycast stuff. Like, you just point to this IP pool and it doesn't matter. Like, you don't have to worry about the data. You don't have to worry about where you're writing. You just point here, you connect, and that's it. Benefits of Pulsar, the multi-tenancy, I think, is actually really important for if you deal with any sort of data residency. Like, you know, I can minimize things, not to bash against it, but like GDPR, I can just have a cluster in Europe and only replicate in Europe and not have to worry about any GDPR implications for any of the US stuff. And you might have a customer that says, like, our data can't leave X soil, and I can actually guarantee that. And still have DR and backups, and, you know, it's not a ton of effort. I don't have to do it in the application code, and I abstract this away from all the devs. Like, it's quite powerful. So we kind of said on the geo-replication, and the multi-tenancy sort of plays into that as well, just segregation of how we do things and what caps. And the Pulsar function is just being able to run on top, I guess, is a nice benefit. So those are the slides. And I have a much more, like, really dive into a technical YouTube video, but it's an hour long as well. And then the entire data platform that we built at BlueCat is this last one. It's about a 6-hour playlist. It covers literally everything. It covers the event streaming, the on-prem versus cloud, to what we're using for our batch analytics, like all Trino, how we're using it to process all the data. Like, it's very extensive, but it's nowhere I can fit that in a talk. Like, there's like 5 videos and each are an hour. But if you're curious on this big data stuff and like what went into it, it's also a nice video because at that time, it's a from the ground up perspective. Like, you get to see a lot of the stuff I cover, like on-prem versus cloud. We actually considered fully on-prem. And why did we not do on-prem versus, and we already had a footprint in on-prem. Why did we go cloud? And what were the trade-offs there and things like that? So yeah, I think we have time for a little bit of questions. I know we're right at the spot, but yeah.